Hi, my name is Hannah Mitchell, and this is my lab, the eye dissection. I'm going to do a quick scan around the room so you can see my workspace. All right, here I have the dissecting tray. I also have my iPad out with all of the structures that I will be pointing out. We're going to start over here with the eye dissection. So the optic nerve is right here in this center here. You can get a better look of it on the back side actually, that round piece there. Brown. And then the extreme stick eye muscles, that's these pieces that I cut out that were surrounding the eye. The cornea is right here. Here's my poker. And then the sclera is this white outer layer. The anterior chamber is directly under the sclera or the cornea here in the eye. And then the pupil is this center here. The iris is this colored portion. The lens is right here. It was directly below there. The retina is this layer in here. And then this black layer, the center layer between the retina and the sclera, is the choroid. And then I'm just going to go over my questions here that I have. It says, for number one, what happens to the diameter of the right pupil when you briefly shine a flashlight into the right eye? So the diameter of the iris, it reduces, so that way less light can pass through to the retina. I'm going to turn on my flashlight here and demonstrate the pupil dilating with light. Okay, through which structures, for number two, which structures, openings, chambers of the eye does light from a flashlight pass in order to reach the retina? So it's going to pass through the sclera, the aqueous chamber, or aqueous humor, the iris, the pupil, the lens, the vitreous humor, and then it's going to hit the retina. Which structures serve as the sensor and the effector in the pupillary light reflex? So the retina is the sensor and the iris is the effector. Which cranial nerves are required for the pupillary light reflex? That is the fovea. What happens to the diameter of the left pupil when you briefly shine a flashlight into the right eye? So the muscles will cause the iris to contract, so it will also reduce on both sides at the same time. So light goes in the right side, the left side's also going to constrict. That will conclude my lab. Thank you.